All right, in this problem, we're gonna look to find the area of this asteroid. Um, and to do so, we're gonna start off by recognizing that this is a symmetric um, area, and so the area of this region right here is 1/4 of the total area. So we're gonna multiply the area. So I'm gonna say note the area in quadrant one is 1/4 the total area. Okay, so we're going to utilize the fact that we'll integrate this area and then multiply it by 4 to find the total area. Okay, all right, so we're going to start by multiplying the area. So we're going to go from the integral from 4 times. This is 4 times the area of 1. We're going to go from 0 to 1, which is the length here, y dx. Okay, so let's plug in what we know. This is going to be 4 times the integral from 0 to pi over 2 sine cubed of t times 3 cosine squared t sine t dt. Okay. Um, let's see. This is sine to the fourth here, and then a cosine squared there. So this is sine to the fourth t. And then using the power reduction relationship, this is the same thing as 1 minus cosine of 2t divided by 2. And that's if it's a square, but this is squared, so we're going to square this. So these two are equivalent. The cosine squared is equal to the exact same thing, but with a plus here. Okay, so let's go ahead and plug in that information. Let's see if it'll simplify our calculation since we have nothing but even powers of sine and cosine here. And so this becomes um, the 3 comes outside. So this is not, we're going to multiply that 4 times the 3 there. And then I have 1 minus cosine 2t over 2 squared times 1 plus cosine 2t divided by 2 dt. Okay. It looks like I have 2 times 2, which I can use to reduce. And then I can factor that term out. And let's see. But this is 2 squared. So this will be 4 and 2. So this will be 8. So I can factor out a common factor of 1/8. And then I can square this term out. So multiply, I'm going to pull out a 1 over 2 squared. That's coming from here. And then 1/2 there. So 1 times 1/2. So that's going to equal 1/8. Also reduce this to what? 3 over 2. And then 1 minus cosine 2t squared is 1 minus 2 cosine 2t plus cosine squared 2t. Okay, which then I can use power reduction on again if I need to. But let's go ahead and see. So that means I'm going to then have 1 plus cosine t multiplied by all of this as well. Oh boy. Okay, so let's see what that is. 1 minus 2 cosine 2t plus cosine squared 2t. Okay, and then I'm going to multiply that by 1 plus cosine 2t, which is coming from here. Again, I factored out the bottoms here. Um, okay, so let's see if I multiply this out. What this one's going to give me a copy of everything that I see here, and I'm going to change everything here to multiply that. So if I do that, I'm going to get that that implies that this is equal to, let's see, we have 1 minus cosine of 2t minus cosine squared of 2t plus cosine cubed of 2t. Um, so I don't see any other simplifications I can do without doing the integral. So um, I'm gonna take these two as one integral, and then I'll break this one up and this one up. This one I'll have to do the integral again of 1 plus cosine of 4t over 2. That's what this is going to be reduced to. And then this one is going to be cosine of 2t times cosine squared of 2t, which then will equal cosine of 2t times 1 minus sine squared of 2t. And then I'll let u equal this, and du will include that. And then I'll integrate. Okay, so if I do all of that, then this is going to equal 3 halves coming from here. This is 12 divided by 8. Reduce it to 3 halves. Okay, so each of these integrals then, this integral is going to give me t minus sine of 2t divided by 2. Oh, looks like I need to write down here a little bit. Minus 1 half, looks like t plus 1/4 sine of 2t. And that's coming from this part right here, integrating that, plus 1/2 sine of 2t minus 1/3 sine of 2t cubed. And all those go from 0 to pi over 2. Okay. All right. So we'll do the upper minus the lower. Uh, all of these are sines or zeros. So actually, the lower term is not going to need to be evaluated. I just need to plug in the top term and see what we get out of it. So we get 3 halves pi over 2, 0, 0, 0, 0. So it's going to be minus 1/2 pi over 2. The rest are zeros. Minus 1/2, 0. Those are all zeros. If you're wondering why it's zero, it's because it's the pi over 2 makes and the 2 cancel out, and this leaves a sign of pi, which is why all those are zeros. Yeah, they're all zeros. Gosh, okay, so this is going to leave pi over 2 minus a pi over 4. So it's going to be a pi over 4. Pi over 4 times 3 halves. So this is going to equal 3 pi over 8. Okay, so that is then the total area. Okay, all right, I hope that was helpful, and I'll see you in the next video.